Hey there, what's up? So what you're about to watch here is a quick mock interview that I did with my good friend Rafael. Rafael is a student at the New Jersey Institute of Technology studying computer science, the same major and university that I attended to. And this interview is supposed to mock what a technical coding interview would look like for a software engineering role at any large tech company, small tech company, you name it, anywhere in between. It's a software engineering role, so you have to know how to code, and that's what this video covers. In the first part of the video, we'll talk about the hiring process at large, talk about what it's like to get recruited, talk about the online assessment, as well as the technical interview and expectations amongst those three components. And then we'll dive into an actual technical interview problem. We'll walk through a code question, and he'll walk me through his solution. He'll write something on the fly in a Google Doc, and together we'll walk through how to optimally solve this problem. I get to see a little bit about his thought process. I get to see how does he code. And then in the end of the video, we'll talk about how to improve on code style, variable naming, and also your thought process and your mindset when it comes to an interview. And I don't mean to sound very woo-woo, but really your mindset is super important for technical interviews and arguably everything in life. When it comes to the technical interview, you have to come into it with the sort of confidence that you've kind of already got the job handed to you. You've got it secured. It's in the bag. And with that mentality, you'll go far. You'll walk in with the unsurmountable confidence that the interview can't even shake. Because you'll be treating them not as someone who's assessing you, but as someone who's a teammate on the team that you've already landed a spot on. So, join me in this video. Watch Rafael go through this problem and see kind of what it's like to actually walk through a technical interview. I'll see you on the other side. Thanks for watching. Essentially, how the whole process works is like this. Either you apply or a recruiter reaches out to you as step one. Step two is they hand you a link to a online assessment. And this online assessment is the step that you're currently at, which you're preparing for. And this is an asynchronous way for them to be able to kind of test, do you know how to code? Just basic coding. It's not like a super extensive test, at least not most of the time. Like, do you know how to code a little bit is really the question here. And it's very automated, and it weeds out a lot of people who don't know how to code, who just applied for the sake of applying, and they wanted to see, maybe I can get into Google, and they think that it's like a job pretty much anywhere else that requires no skills. But coding, as you know already, Raf, it requires a lot. Okay? Now, when you get that online assessment, it's usually 1, 2, maybe 3 questions that you have to answer within an hour or so. For the sake of this prep interview, we're going to just go through one question, and we're going to walk through it pretty detailed. And this will actually mock the next phase of the interview process, which is not the online assessment. It's going to be the actual technical interview. So the technical interview, really there's the technical interview and the behavioral interview in one. So this is the conversation that you have with me, an engineer on the team or a hiring manager or something. And we get to know each other. I ask you about your background. I ask you, I kind of measure, like, is this somebody that I want to work with? Is he like a cool human, a cool person that, like, I would enjoy having on my team? Is he not just like a robotic code robot, you know? Right. I want to work with humans. I want to work with people. I don't want to work with robots. Right. Maybe some people do, but the large majority of people want to work with other people. Okay? Right. And so that's the behavioral half of the actual interview. The technical half is more about algorithmic style questions, data structure questions. And these can range over a wide variety of topics, as I'm sure you know. Some of them can be pretty esoteric and very deep and very hard. And they may be covering things on the order of graph problems, DFS, BFS, or they could be on the order of bit manipulation, and you need to know some really like strange mathematical theorem. Most of the time, it's not like that. What they really care about is not that you know how to pull this one tiny little piece of information that nobody else knows out of thin air in the pressure of an interview. But what they really care about is, how do you think? Even if the question is very hard, can this guy walk me through his thought process of a technical interview problem well enough that I understand? Maybe I know the answer, maybe I don't know the answer, but well enough that, like, I understand a solution. If it's the optimal solution, excellent. If it's a solution, good. If there's no solution, then, well, sorry, you're going to have to go to another interview with another company. But that's just the nature of these things. You're not always going to get it, right? Obviously, it's great if you do, and I encourage you to perform well so that you do. That's the goal of this. We don't want to get rejected. But the reality is sometimes maybe you were just having a bad day, or you didn't know the answer, or stuff happens. But at the core of it all is, how do you think, and can you communicate that well to me? Okay? It could be a really hard problem. It could be a really easy problem. It doesn't matter. Okay? How does that sound to you so far?
Sounds good. Sounds good. Very excited for this.
Awesome, man. Any questions before we dive in? I know that you said that you're excited for this and that you're not so confident about your technical coding abilities, which I'll
Right.
pretend like I didn't hear, but I think that you definitely have what it takes. If you made it this far, I think that you have what it takes.
All right. I have no questions so far.
Cool. Cool. All right, so let's get right into this. So, Rafael, nice to meet you. My name is Ricky. I'm glad that you could finally join us today to talk about, well, interview with Google. This is, a great company that I'm sure you've heard of, and I'm excited to hear about why you decided to join the company. Tell me a little bit about yourself and your interest in Google as a software engineer.
Right. So as you may know already, I'm Rafael. I'm Dominican, and I've been here for 5 years. During my college career so far, I have been exposed to many coding and many new concepts that I just love so far. Um, your question about why I decided to join Google, mainly because the community that you guys have, and I feel like I'm going to be a good asset to the team at Google. So so yeah, I'm just trying to expose my capabilities and show you how capable I am to do the work.
Cool, cool. So you said that you love coding, and there's a few things that's coming, that you've learned over the last few years. Can you tell
Right.
me like any sort of projects or programming languages that you've worked on?
Of course, I would love to tell you my experiences. So the latest experience that I had was during the semester. I was working with an organization, and I was tasked to do some data validation for a spreadsheet, basically making sure that the data is correct. And if the person is missing information, I just had to send an email, just very basic. Everything was great. I used pandas. If you don't know, it's a library in Python. That's which is very good with data analysis and going through Excel sheets. And yeah, so I had to learn the new concept. I spent few hours reading the documentation and then going through the code, very basic Python coding. And I found that very interesting, how we can manipulate data and how can we use different sort of methods and algorithms in order to put everything together in a meaningful manner. Uh, fun fact about that project is that after my algorithm was done with sorting the data, I was sending the emails right away. So I was sending individual emails to each person, and I CC my boss in every single one of them. So I ended up sending more than 800 emails in less than 1 hour. Yeah,
800 emails?
yeah. So what I learned from that experience is that I must take my time and double check my code instead of just trying to finish it up really fast and showing that I can do the work. So I understood that I had to just take it easy and not rush because I can make big mistakes. It wasn't that big of a mistake. However, I had to, rethink my thought process, because during my thought process, I was like, yes, I'm gonna send these emails to every person, and I'm gonna CC my boss so she can see that I can do the work. But there, yeah, basically that.
Nice, nice. No, I can definitely relate to that. I've been on both ends of that coin. Uh, I've been on the one side where I've sent the emails to 800 people and by accident. And then I've been on the other end where someone sends me an email and it's a thread with 800 other people that are just replying, replying, replying. And it's one of those like long email chains that I'm sure you've
Right.
seen, that people just tend to, hop on board, meme a little bit, and then make some fun out of it and just have a good time, because you have an audience of 800 people that you typically don't have. You're in the palm of their hands, or you're in their pants pocket, and you're just buzzing away, right?
Right.
So it comes with a little bit of, with great power comes great responsibility, right? So you have a
Right.
large email list, and you want to work through this through software, through coding. It requires a bit of thought. You have to be careful, because in some cases, an email is relatively harmless, right? Maybe it's a little annoying to someone, but who cares really, right? You're just sending them an email. But in other cases, things that are more severe, say traffic data that you're working with, that you're trying to route people through traffic in a busy street, or search results during a very turbulent time. Like, for example, this past week we had really crazy weather where the air quality outside was literally orange. The skies were orange and yellow and red, and people might be curious as to what is going on here. So it's up to your code, it's up to your software to properly identify these sorts of inputs and generate the right sorts of outputs. So, of course, it's important, right? And you're learning, and this is a part of the process. So I'm glad to hear that your story ended at least on a fun note. It didn't seem like anybody got killed through it, or got
Right.
some sort of lung
Right.
damage.
Just a
with
little
smoky
annoying.
air.
My boss was like, "What is this?" I'm like, I'm sorry."
Just some mild frustration. Good.
Right.
Good. Which
Right.
is
She
totally.
was kind of surprised though. She was kind of surprised. She was like, "How can you do this in less than 1 hour?" So I had to explain her the process.
Of course.
Yeah.
Just to confirm that you can see what the same thing that I'm seeing, can you just go ahead and type into the doc "Hello World"? Perfect. I can see it.
Yeah.
Awesome. One thing that I'll do for you, and this is just for both our sake, I'll put in a monospace font. There's no highlighting, there's nothing along those lines, but at least it's monospace, and it's not variable space. Okay. So I want you to tell me a little bit about strings. What do you know about strings?
They are mutable. No, actually, you can sort them, you can break it down, and they're a way you can do many things with them. Actually, they're words. They're everything.
What do you mean by that?
You want me to explain it to you in a technical way?
Yeah, let's
Yeah,
let's start.
of course. So
Let's start a
what I know,
little. Well, hold on. Let's start simple. Let's pretend like I'm your 5-year-old little brother, and I'm asking you about code. I'm peeking over your shoulder one day. You're on your laptop coding away, and I see the word string s equals hello world on your screen. And I say, what's a string? Because what I think a string is what my shirt is made out of. All these tiny little strings.
Right,
Or a
right.
string to hold up a piece of paper, or a string for something else. But
Right.
in a technical term, to a 5-year-old, what is a string?
For a 5-year-old, so a string. Let me put everything together, right? Let's say that you have a combination of letters, right? Then you want to put them together. Then you can form a word, or you can just have single letters too. As long as you have them um, in double quotes, between double quotes, that's a string. Whatever you have between double quotes, that's a string. It can be numbers, it can be letters, it can be anything. It's gonna be treated as a string. You can print them, you can see them on the screen, or you can actually manipulate them and go through them and break them down and create a new string out of them. Uh, so a normal definition of a string for you right now as a 5-year-old, I would say just think about a word. Just think about a sentence. It can be a string. That's a string for you.
Okay, so a string is text, is what you're saying.
Yeah, text. Yes.
Okay. So sometimes they're letters, sometimes they're numbers, sometimes they're
Yeah.
symbols, I imagine too, right? So like
Yeah.
apostrophes, at signs, ampersands, parentheses, all these
Right.
are characters
As
that could
long
be
as they are between double quotes.
okay, within my programming language. Okay.
Yeah, between your program.
Okay. So what programming language are you comfortable with today in coding with?
Today I'm feeling like Python.
Python. Good choice.
Yes.
I like Python too.
Yes.
Okay.
Yes.
So I wanted to ask you about this specific problem with programming in general. And you may have seen this if you've ever programmed before in Python, or maybe other languages that have a bit more symbols involved. Python is
Right.
a bit quirky where you indent with white space and you don't have blocks of code with brackets. Maybe you've programmed in Java, JavaScript, or C++ in the past. I know in Java you have some code that sometimes looks like public, static, void, main, string, args, and then you have system.out.println, and it looks like hello. Python isn't like this at all.
Right.
Python, on the other hand, it's just print hello
Yep.
world, just like how you have above.
Right.
Okay, so this would be Java, and this would be Python. But let's pretend that you are creating a new programming language, for example. So let's call this Rafael. And
Right.
you wanted to create the interpreter for this language. And the interpreter is what reads the strings of text, and it has to understand what is going on in terms of the grammar, in terms of the syntax, in terms of are you following the rules of the language? Because as we see here, Java and Python have two different syntaxes. And as you can imagine, JavaScript has its own, Rust has its own, and so forth. So it doesn't matter what your language is, but let's start with a quick little problem here. I want you to be able to tell me if you were developing your own interpreter and you wanted to balance the sorts of parentheses and make sure they had a properly formatted function, so to speak, or code snippet. I think code snippet is what we'll call it here.
Right.
If I handed you this as a code snippet, I want you to see if the parentheses are balanced. Okay? And what I mean by that is, see here how we have a set of round parentheses on the outside and then a set of square brackets on the inside. And then as you continue on, you have these curly brackets on the outside, and then you have these round brackets on the inside. So in this current case, we have a set of balanced parentheses in Java. Python here too, right? Now, let's start pretty simple here. And let's say that your input string looks something like this. And I hand you over this as your string. And I say, let's create a function here called check for balanced parens, and it takes your input string s. You said you wanted Python, right?
Right.
So I would like you to come up with an algorithm here that is able to tell me if this input string s returns a balanced set of parentheses.
Right. Okay. All right. Great. Sounds good. Thank you for your clear explanation. I couldn't ask for a better explanation than this. Only question is that the only rules that we have is that, for example, if we have something like this, and then we have something like this, right? That's wrong, right? In this
Correct.
case, or like the string that you're giving me is gonna be between those. Like it's gonna be like inside. So for example, we have these parentheses, and then we have more stuff. Like if we have this or this, and then if we have words, we can just ignore the words, right? The letters.
For the current system, let's pretend like there's no letters involved and you have what I'd call a clean string or clean input.
Okay.
You can just ignore all letters for now. And
Okay.
imagine that your input string doesn't even have letters to begin with. It only contains characters in that look like this, like that,
Okay.
or like this.
Okay.
If we want to get fancy, also those.
Right. So for which characters do you want me to check? Only parentheses so far?
These sorts of parentheses. So I would call these round brackets, square brackets, curly brackets, angle brackets. So imagine that these are the only characters that your input will ever see.
Okay.
No letters are involved.
All right. So, brackets. All right. Great. 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 Out of my head, as you're passing a string, I'm thinking of um doing a for loop. Um, I'm getting each letter or each character from this from the string, and you want me to return true or false, or you want me to return something in this case
Yeah.
if it
I
was true.
I would like you to tell me if the
Okay.
string that's inputted is balanced, and I think a boolean is a proper output here. So true or false, is
Okay.
S a balanced string?
Okay. Okay. Great. 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 So for this example right here, I'm just gonna um, first of all, the thing that I told you is that I wanted to break down the string and get each character of them, and then after that I can go through. I can check if the next one is the matching one from the previous one, right? So I will create actually I will make a dictionary which will hold the opening bracket, or yeah, the opening bracket as the key and the value as the closing bracket, right? So I'm just gonna call that right now. So uh, my brackets indentation is important in Python. I will create this open parentheses as a key, and then the closing one as a value. Um, I will also make the other ones just in case if we want to pass more values, so we can work with everything, right? So it would be uh, we make this, right? So it's just making a dictionary. Dictionary is just data structures where you can hold key and value pairs. So if you're looking for something and then you have is and then you're looking for the definition of it, you can just think about it like a normal dictionary that you have, and then you just looking for the word hello, and then you just go to the definition. This is the same thing. We can call it and we can find the definition of each thing. So like uh, then we have this, and then the last one is getting tedious. Right. This is the opening, and then this is the closing one. Right. Hopefully my syntax is proper. So that's our dictionary of brackets. And with this, I'm gonna be able to check for the values and make sure that they exist already in the, I'm sorry, in the, oh my God, in the, I'm gonna rephrase my wording right now. So after this, what I want to do is to create a way to track the how many opening brackets do I have, or the opening brackets that I have, and then to see if I have a closing bracket. So for this, we can use a basic data structures that we have. Um, I would like to use the stacks. So we can use stacks for this manner, and then we can just check that if the opening bracket exists, and then the next one is a closing bracket, then it means that it's a valid string per se.
Okay.
So a stack is a LIFO, uh, last in first out. So whenever we are inputting into the stack, we have to make sure that the next one is a matching a string or character from the previous one. So that's why I created the brackets, because once we get into the stack, we can make sure. I mean, well, that's why I implemented the dictionary. So that's why once we get into the stacks, we can make sure that each key match their values.
Right, because you wouldn't want to match a round bracket with an angle bracket, for example. So you
Right.
want to make sure
Right.
that there's there is complement.
Right.
instead of mismatched.
Right.
Okay.
So I'm just gonna call on Python. We don't have stacks in Python, so we're just gonna use arrays in this case. Arrays is basically the definition of arrays. It's just I would like to call it as well. In Python, it's a list, so it's just a list of things. It can be anything. It can be whatever. You don't have to declare the data type of it. So in this case, we are working with strings, so we're good with that. So next thing that I would like to do is to iterate through each um, character of the variable s that you created right here, and to check that if it's not in the stack, we can put it inside, right? Oof, I'm getting nervous in this in these explanations. All right. You have any thoughts so far of my thinking process?
So the way that I'm understanding it is that you want to use this data structure here. You have two data structures. You have
Yes.
a dictionary for your brackets to make sure that, round brackets map to round brackets, square brackets map to square brackets, and so on.
Right.
And you're going to use a stack to somehow iterate through the input string and, I guess, keep track if everything is balanced.
Right.
I'd like to see more about how you'd actually go about doing that. Do you think you could go through
Sure.
a little bit of sample code and maybe walk me through, or maybe some pseudo code here to get
Yeah, I
a
can
more
make some
concrete
too.
idea?
Yeah.
It's okay if
So
the syntax isn't perfect. I'm looking more for
okay.
just a general outline, and then we can go and work in details later. But let's go
Oh,
through maybe just a few comments in code
okay.
and work through there.
Right. Perfect. So the why I created the stack is that if the stack at the end of the iteration is empty, that means that we have a valid string. So per se that this is a comment. So per se that if we have the first letter or character in the string is an opening bracket, and then we get a closing bracket, we can just take it down the opening bracket, right? And then the stack is empty again, and so on. If we get another bracket, like this bracket right here, and then we get the closing bracket, right? Then that means that it's a matching string, and then we can just delete it all. So at the end of the iteration, we can get a true or false, and if the stack is empty, then we can say that it's a valid string, right? So I'm just gonna write some pseudocode
Go for it.
for. I'm just gonna write some pseudocode basically for each char in S. We can say that the character, if the character, well, uh, well, actually check if the character is in the stack. If the matching character is in the stack, and if we get the closing one, if we get the matching one, we can say that we can just take that character out of the stack. So we can just we can just take it out. So like if matching values in stack, uh, we can then. I know there is more to it, and now that I'm thinking, I would actually um, like to iterate twice through the stack. No, I'm sorry. I apologize. So I'm gonna go with this. Okay, I'm gonna go with this.
Sure, sure.
So for each character in the S in the string, we want to check if the character is in the stack. If it's not in the stack, we can add it. We can add it. Right. Um. Right. If it's not in the stack, we can add it. And then after that, we can just take. Uh, after that, we get this. So we can just Um, I'm getting a mental break right now. Sorry. Um, After that, we can just check if the values. No. If it's okay, if I go back from the beginning,
Sure,
we'll have
whatever
fun.
works for you. I think that
Yeah.
we'll call the interview at 10:30, so we'll have
Okay.
45 minutes left.
Great, great, great. My thinking process is just kind of messy right now at the moment. All right. So we want to make sure that this is a valid string, right? So we go one by one, and we're using a stack data structure. So we want to check if the next character it's is a matching character of the second one. So if it's a matching character means that the values of the if the key match with this, then it means it's a matching character, right? So all right, so let's do this. I'm just gonna jump straight to the algorithm. So for I in S, right, a stack dot append. We use append in order to add the new characters into the stack, basically.
Sure.
That's how we add into the stack, right? So for I and S, we added to the stack, right? Um, I would like to put more conditions into this. So
Don't worry too much
if,
about the capitalization or anything. Just go with it.
if I not in stack, we can just append it to it, right? Actually, um, if I not in stack, okay, um, we can just add it to the stack, right? So stack dot append. Right. After this, we're getting, for example, the first character in S is the open parenthesis. So if the next one is a closing parenthesis, then that means that we can pop it out. We can take it out of the stack. So that means
Got it.
it's a
That
valid
makes sense.
yeah, it's a valid string. So yes. um, so if we say that if in this case if s s to is equals to uh, for ins, so we get the open parenthesis, and then the next one will be the closing parenthesis. So if s is equals to the stack, we want to find the key first, and then we can get the value out of it. So if it's in the stack, then we can just pop it out. I have to put something in here. So but I know it's just we just pop it stack dot pop, right? And if the stack is empty, stack return stack if it's empty. Um, so here, how do I get the key? So we want to make sure that if s is equals to the key to the value of this key. So for that we have opened this. Um,
If I'm understanding, we want the last. So a stack is a last in, first out data structure, like you mentioned, right?
yeah, last in first out.
So
Yeah.
we want to take the last thing that we added to the stack to check if it's worth popping or if it's a correct
Yes.
match, right?
Right. Right. So thank you so much for that. So we are gonna pop the last thing that was in, right? So uh, pop item, for example, pop item is gonna be So we are appending and then we're popping it out. So like that doesn't make sense at all because it's just being zero after that. I was gonna make a big mistake right here, right? And I'm working to a solution. Okay. So
You're
for
doing
each
great.
character,
Keep going.
yeah, yeah. For each character in S, each character is each string. So we appended. If Do you mind if I take notes in my notebook?
Absolutely.
Yeah. Okay. All right. Yeah, I better work with my notebook, all right? So for each character in S, right? S. It's this. Right. So we are if this is stack, right? So if item, I'm gonna take a deep breath right now. If the item is if the item is not in the stack. Okay. If item if stack. I'm sorry, I'm using the wrong one. I'm using if S my brackets. Sorry. I realized that. Yes. If the Because we want to get the keys from the dictionary that I made, right? So we are comparing this. Um, I'm using the wrong. I'm also using the wrong variable right here. So I is each character in the string, right?
Sure.
If I is equals to my brackets, and let's say we have this, and then we want to make sure that this I is gonna be equals to the last item. So it's a matching value of the last item. So um so my temp character temp character equals to my stack dot pop, right? So if this I is equals to the same so if this temp character is basically getting the last value of the stack, and then if the I is matching this dictionary value, let's say temp character, temp character, right? Then we can just take it out, right? I know I have some bugs in here.
That's okay. So, how about we do this? How about we run through a few test cases? Why don't you come up with 2 or 3 different example inputs, and let's see if we can walk through your code line by line.
Right. So let's say we have this, and then I have this, and then I have this. Right.
Let's just start even with the simplest of cases, just the round brackets up above.
Right. Okay.
We can move on to this one eventually, but let's just start easy at first.
Right. 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 Okay. Yeah, it's better. So we're getting each character in the string with I, which is I. So we first get this one,
Uh-huh.
and then we add it to the stack. So now this stack in the first iteration, it's gonna be sorry, it's gonna be a stack. Uh, it's gonna be like this at the first iteration. Then temp chart is gonna be the last item, the key in this case of of the thing that we just pop it out basically. I'm not sure. I'm pretty sure that this eliminates the entire thing in Python, or I forgot.
I believe it does remove it. Are you trying
Yeah,
to remove it or
I'm
just look at
I'm
it?
trying to say, I'm trying to look at it.
I would, in this case, I would probably use the lookup operator. So I would say stack brackets minus one to look at the last element.
Right, right, minus one. So right here we are getting the last element of the stack, which is in this case the only one that we have, right? So if I, in this case, the opening bracket is equals to the temp chart, which is the last element. So I is the opening bracket that we have at the moment, and temp chart is just, and this variable right here basically is getting the value of the temporary, which is in this case is the same as I. Yes, it's the same as I. And then if we get them to match, then we can pop it out, right? But in this case, in the second iteration, I'm getting this. So I'm getting this. So the last item in this case is this. And the temp chart is then it's not gonna work, because then if we get this and I is the temp chart, then there is no key for this in the dictionary, and that's a problem.
Okay.
um,
So how can we
yeah,
work towards resolving that bug?
we can switch. We can create more conditional statements in this case. Let me write something down. So actually, um, in this case, I want to. Do I want my stack only to be the opening brackets?
I'm not sure.
I'm not sure. No, I'm sure. Um,
What do you think would be most efficient?
what I think would be most efficient would be only to add the opening brackets into the stack, and
Okay.
once we find a closing bracket, then we can just take the last item of it.
Okay.
It's, yeah, which I'm trying to do right now. um, so I'm just gonna switch things around a little bit.
Sure.
Yeah. So for INS, if each character is in S, if 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 my brackets if my brackets is not in on my stack. So once I call this, I'm asking for the key of the dictionary. So as we only want keys, we can just append it to the stack in this case. So if the brackets is not in the stacks, then we can add it.
So my brackets would be the entire dictionary, right? So I would probably be comparing this and checking if this entire thing that I'm highlighting is in stack. So is that truly what you're trying? Because I don't think that that's what
Um,
you're intending.
I'm trying to get each key of the dictionary. Um, I'm not very sure. I think this allows you to check each key, because you're only checking for the keys of the brackets, if I'm not mistaken. I'm not sure. I'm pretty sure I did this. I printed out just testing, and it just got me the keys. Um, but in
Okay.
that case, yeah,
So what is it that you intend here? Let's write a comment first. I would write a comment to see like what do you mean just in simple English.
right, right. So for the stacks, for the stack, I'm trying to get all the keys, all the opening keys, right? Uh, all opening brackets, brackets. Right. So I'm just trying to get all the opening brackets, and oh wait, if my bracket's not in stack, then append I. If I equals
Just about 30 minutes left. Just want to keep you in.
right, right. So I've taken less than 10 minutes. It's just the nervousness, but it's alright. Alright. Um, if I is equals to my brackets time short, so my time short is if my bracket's not in stack. So I'm trying to get into the mindset of finding the opening key, getting the next one, and then making sure that they match. So if I find the opening key and then I add it into the stack, then I get the next one, and I can just get the I can just call the and if it's a valid one, yeah, then yes, makes sense because we want to make sure that these are valids and these are valids and these are valids, right? So all opening brackets, and then we need to match them with our closing bracket. So in this case, if brackets not in stack, stack dot append I. So it's getting all the principal keys, and then if I is equals to my bracket temp chart, which is the last. I think I misunderstood your explanation a little bit, and that was my first problem here. Um, temp chart is equals to my last character, and if I is equals to my bracket temp chart, I can just take that out of the stack. So in this case, for example, let me go one by one through this code. Right.
Sure.
So if we get the opening bracket right here, then it means that it's not in the stack. So this is not in the stack. Um, I haven't, okay. It's not in the stack, so the stack is gonna be like this. It's gonna be like this at the moment. And if I, in this case is this temp chart is gonna be uh, the last the last the last item in my stack. Then I can see I, which is also this. If they are equals to each other, because we only have keys in here. If this is a closing bracket, then we can take it out the stack. And once we do that, we can just say if the stack is not empty, we can just return true. Uh, if stack, uh, if len of stack, I just said this way, equals to 0, then we can just return true in this case. As, sorry, that was Java. As return false.
All right. So let's go through a few different test cases here,
Yes.
line by line. So let's start with an easy one. Come up with an easy one, and then we'll go through it.
Right. Okay.
Let's come up with one valid case that should return true and one
Yes.
invalid case that should return false.
So this is a valid case in this case, right?
Sure.
And then this is a invalid case.
That looks fine to me.
That will be an invalid case.
All right, so let's test them.
Right. Right. So okay, one by one here.
Yeah.
Okay, sure. So let's go to S. Right. For I in S, S is being passed as it's an argument on the on this on this function. Is okay. So it's being passed into this function, and then we have created our dictionary right here. We have our empty stack at the moment. For each character in S, we're gonna check if the sorry, if I not in my brackets. That's a little bug right there. I had. So if I is not in my brackets, so I can append it into it. So like in this case, the first one, I at the moment is the opening bracket. I mean the opening parentheses.
For just clarity's sake, I wouldn't write our notes in the middle of the code. Why don't we write our notes kind of in the bottom here?
For sure. I apologize. Okay. So whoop. Okay. So I at the moment is an opening parenthesis, right? It's checking if the if okay. I see where I messed up a little bit. Right. My first conditional statement is not checking if it's in. Oh, there you go. That should fix it. All right. So in this case, it's checking if the I is a valid key in our dictionary. So if I is a key, I mean, is a key in our dictionary, then we can just append I into our stack. After that, we get a temporary character that is basically the last item of the stack. So our temp chart is equals to this at the moment, right? If I, which is this, is equals to the my brackets temp chart, which is a key, we should get my brackets temp chart would be. I'm just gonna temp. It's gonna be a closing bracket because as temp chart is a valid key, we're just gonna get the closing value, right?
So
If
what you're saying here on this line is if I, which is a left parentheses, is equal to a right parentheses, then pop it. So what happens if
not?
So if the left parentheses and the right parentheses, if this is a complementary pair, meaning round bracket with round bracket, open with close, then we pop it off. What happens if, let's say, we see a different kind of bracket? Let's say instead of a round bracket this time, there's a square bracket. Well, we'll finish your test case now, but that's something to keep in mind.
Okay. So at this point, I'm just working with this kind of example, right? So so right now my I is gonna be the opening bracket, my temp chart is gonna be an opening bracket, and then my bracket is gonna be a closing bracket. So as for they're not together, it's not gonna do anything. It's just gonna continue with the for loop. Next, we have the I is a closing bracket. So as for I is not a valid key in this case, we're just moving to the next one, and we're and it's not adding into the stack. So after not adding to the stack, we get the same we get the same last key, which is temp chart, which is the same opening parenthesis. And then as for I is a closing parenthesis. We check if it's equal to the my brackets temp chart. In this case, it's gonna be a closing parenthesis. As for these two matches, it means that it's a valid argument or string, and then we can just pop the last item out of the stack. So we're taking out, then now our stack is gonna look like, after making sure that these two are equal to each other, that the temp chart and my brackets are equal to each other, my stack is gonna look like an empty stack. And then we're gonna go through the next one, right? So we're gonna go through the I, which is gonna be a opening bracket, same process. We're gonna append it into the stack, and then we're gonna check that we're gonna get the same value, and then we're gonna check if it's if this is an opening if this, as for temp chart, are only keys. If this I is equals to the value of this, then we pop it. As it's not, it's gonna continue with the loop, and it's gonna get the next one, which is a closing. So I is gonna be a closing bracket. Temp chart is still gonna be an opening bracket, and then my bracket temp, which is temp chart right here, is gonna be a closing one. So as for I and my bracket temp are equal to each other, then I'm gonna pop it out, and my stack is gonna look empty again.
But they aren't equal. Oh, yeah, they are. Excuse me. Sorry.
Yeah.
I was reading something wrong. So they are equal. So this and this are equal. And then that would pop off the stack. Okay, so let's work against a different case.
Right.
Let's try this second invalid test case.
Okay. So so we first pass the S as the definition, right? So we pass it into our function, and we get an opening bracket as an I. So the opening bracket is gonna be our valid key in this case, and then if I is in brackets, it's gonna append it into the stack. So our stack, I'm gonna delete this right now. Our stack is gonna look like this, an opening one, right? And then it's gonna get the temp chart. It's gonna get the last item. It's gonna get the last item of the stack, which is gonna be that one as well, right? Then I'm gonna check if I is equals to temp chart, to my brackets temp chart, which is my brackets temp chart. I'm just gonna, can I call it MB? MB in this case. My brackets temp chart is gonna be equals, actually, my brackets. It's gonna be equals to the, as temp chart is a key, we get the value of it, which is gonna be this. They're not equal to each other, so it's gonna be the stack. I mean, I is gonna be this, right? So so it means that this one is an opening one, and the one that I'm calling is the closing one. So I still need that the I need to be the closing one in order to be valid. So next, or I is gonna be equals to, and then because they're not equal to each other, we don't pop anything out. So in this case, I is gonna be, and the next iteration, I is gonna be the closing bracket. Gonna be the closing bracket. It's gonna be the closing bracket, and then we're gonna go through it again. So as for I is not one of the keys in the dictionary, we can just skip this part over here, get the same. As for we didn't append it into the stack, we can get it. We can get a temp chart equals the opening parenthesis, which is the last item that we added. Then we check if I is equals to my brackets temp chart, which is not, because I at the moment is a closing bracket, and we need and temp chart is a parenthesis, the key of the parenthesis. My brackets is actually going to be a closing parenthesis. As for they're not equal to each other, we skip this part of popping, and then we're done with the for loop. Right here, we're checking the length of the stack. If the length of the stack is equal to 0, we return true. In this case, as for we didn't took anything out of the stack, that means that the stack length is equals to 1, and then we return false.
Okay.
Yeah.
Okay. So what would the so actually before I ask that question, how do you feel that this is a sufficient amount of test cases to, I guess, cover the world of possible inputs, assuming that there's only symbols like parentheses inputted? I'm not talking about characters or like letters or numbers yet, but in terms of all the brackets, do you feel that these test cases are enough?
Uh, I don't feel like these test cases are enough.
Okay. What
Yeah.
other test cases would like to see here? I'm not going to say test them all, but if you were to just
Right.
dump a handful of different test cases into this question, what
Right.
would you like to see?
Um,
Imagine you had
for
an
example,
automated testing suite that plugs in this function a billion different times with a billion different inputs. What would this
right,
look like?
right.
What would a handful of
So,
them look like?
so I would say one interesting test case that we can add to this would be an opening and a closing one, and then we can get the uh, we can get another valid one, which is an opening bracket, closing bracket, and inside of that we can get, for example, another parenthesis.
Mm-hmm.
I would say this is a valid test case as for this one is matching this one
Okay.
is matching this one, and then this one is matching this one. Right, right. Um, in this case, I would have. Uh, do you mind if I go through it one by one?
We don't have to go through the test cases. I'm more so
Yeah.
looking here for what different kinds of inputs would we want, but we don't have to go through how the algorithm would work step by step for each input.
Right. So, like the different type of inputs, as I show you, we can get something
Mm-hmm.
like this.
Something that's
Uh,
nested.
yeah, some unnested one. Then one example that you show me would be like this, and then we can get something like this, right? Which would be invalid in this case, as for we don't have a closing one. So every single
Uh-huh.
one needs to what happen?
I just said aha, agreeing.
Ah, yeah, because every single special character or bracket needs to have either an opening one. First, we need to check that there exists an opening one. Uh, I would say that this is a test case as for this one is matching this one, and this one is mainly matching the next one. And as for this one doesn't match each other, then it continues. And in this case, it's invalid because as it continues, the last item into the list will still be this one.
Okay.
Yeah, yeah. So I have some bugs here because as for I continue with the next item. This is not added to the stack as per it's not a key. And then we get the last item to match with this one. So at the end, we will still have um, invalid string, and even though it's gonna return true.
Got it. Okay. Well, at least that's
Yeah.
something that you were able to find just through the process of testing.
Right.
Okay. So we only have a few minutes left here, so I wanted to take these last few minutes to ask, um, knowing what you know now, okay, and in the current implementation of your approach, like, what is the efficiency here of your algorithm? What are the runtime complexities and the space complexities of this algorithm here?
So um, the time complexity of this algorithm will be on. So as I'm going through every single character of the list, so I'm running n times for this for loop right here, and the stack. I mean, sorry. So yeah, it would be O n as I'm running through every single one of the characters in the string s. So yeah, so it's running n times, and then I'm appending, which is O1, and then I'm getting the values of the dictionary, which is also O1. So
Got it.
the final time complexity will be O(n),
O of
in
n,
this,
where n is what?
where n is each character in the string.
In the input string.
Yeah, yeah, in
Got
the
it.
input
Got it.
string.
Okay.
Yeah,
I see that you're obviously using a few data structures here, such as the my brackets, as well as the stack here that you've declared. Do
right.
those cost anything?
You mean in space complexity or time
Yes.
com- space complexity? Uh, um, for the brackets, my brackets, dictionaries, they run on n time complexity, so I will say on as well.
Okay.
And stacks or lists, they also, I'm sorry, my brackets, they run into O1 complexity, time complexity. Yeah. And stacks, they mainly run into space complexity. Basically.
Right. And then
Yeah.
for your current approach, at least the way that I'm hearing it, you mean that they mainly run in O of n. But what about the current approach that you're using right now? Is it also O of n? Could you walk me through why or why not?
So I will yes, it's on because I'm iterating um, every time, as long as the string is. So um, the amount of characters that I have in the string, I'm running through it. So uh, I, in this case, is a character in the string. Let's say we have a input like this many inputs. Right, then it's gonna run. Sorry, I just put down 90. So it's gonna run the amount of times that how many inputs we have here. So that's why it makes it on, because it's going through each single one of them, and it's checking that, um, and it's checking if it's a key, and then it's checking if it's matching the values with the dictionary in this case. So in this case, I would say is on. Uh, Worst time complexity would be on as well. So I think, yeah,
Okay.
it would be on.
Do you see any other chances for maybe optimizations? Imagine we had a big string that took up a gigabyte of storage that had a billion parentheses. Is there any way to maybe like cop out kind of halfway through or anything like that if we had an invalid parentheses halfway through that billion character long string?
Right. Can you repeat your question again? Sorry.
So let's imagine that we had an input string s. Here I'm running it at the very bottom of the document, and it had a billion of these. It just looked like that.
Right.
But somewhere right here we had a curly bracket, one of these.
Right.
Is there any way that we can optimally say, hey, we know at this point, just you and me humanly, we think,
Right.
this is an imbalance, this is an unbalanced set of parentheses. But how do we say that programmatically? Because what if this is somewhere maybe here at the very beginning? We have something like that, or like this, or like that.
Right. Right. Um,
And
and then we
assuming that
don't
this
find.
is huge, assuming that this is like 1 gigabyte worth of data.
Yeah. So assuming that at the moment the most safe thing to do is that at the moment that we realize that the next one is not a matching bracket, closing or matching. In this case, it's a closing bracket, so we know that the previous one is not matching them. So like we have to break the loop right away, so we don't have to keep looping. As for we don't have a valid string anymore. Um, and then yeah. So somewhere around here, I will add a break statement once we find that the previous one and next one are not a matching string, um, or they don't belong to each other, then we can break the for loop in this case, so it doesn't go through the entire string.
Okay. Okay. Sweet deal. So I know we only have a few minutes left here. I wanted to open up the floor to you to see if you had any questions for me. I've had a pleasure here sitting with you, walking through this problem with you, Rafael.
Right.
So, yeah, any questions for me these last few minutes that we have?
For sure. I will ask you, uh, what would you think at the beginning of the program of the problem if it was the first time that you would hear it?
I mean, I remember the first time I heard this problem was back in university. I remember when I went through this for the first time. And if I have the utmost honesty here, I definitely would have Googled it.
I was tempted. I was tempted. Yeah.
But jokes aside, I definitely would have thought about how do I go through this in a sort of clever way using some sort of data structure, right?
Right.
And I think that you eventually stumbled upon that. The data structures that immediately come to mind in these sorts of environments, in these sorts of interviews, is always like hash maps or dictionaries in Python, as well as stacks. Because the reason why a stack is so efficient here is because you have a pairing of things that you want to see, kind of like, is this last thing closing this other thing? You're opening a loop, am I closing it right away? And stacks do that very well because of the last thing that I saw. Hey, does this new thing that I'm seeing currently match the last thing that I saw previously? Stacks are very good at that. And so that's exactly what this problem is asking, right? In terms of parentheses matching. This current thing that I'm on, this closing bracket, doesn't match this previous opening bracket that I saw. So I definitely would have thought about stacks along the way there.
Right.
Graphs, hell no. Trees, even less. But, of course, these sorts of linear type problems where you have a nice long string and that's your only input, you can think to your basic stacks, queues, lists, and hash maps. So you did the right thing here bringing those up into the equation.
Great.
Yeah. Anything else?
That's it for me at the moment. Thank you so much for your explanation.
Rafael, this is awesome. We can take off our interview hats now and we can walk through it.
Bro, I did this problem before the interview, bro. I did this problem before the interview on Lico, bro. Trust me. I did it. I did it.
Yeah, I believe you. And
Oh my god.
the hardest part about the interview
Oh my god.
is the emotional management that has to come into it.
Oh my god.
Managing the stress. And
Yes.
You're okay. Look. Here's the thing, man. You haven't died. You've gone through it, and this is just practice. And you should just treat it like that, as practice.
Oh my god, that's so embarrassing. Oh my god.
And here, me, on the other hand, I didn't know that until you told me. So, for me, it's like, hey, this guy knows how to work through a problem. Sure, this is a pretty common and popular problem, but you walked me through a good amount of it. I do have some feedback for you that I like to share, though, because there's always room for improvement here.
Yeah.
So, I think that the first thing that I would definitely suggest you do at the very start is start with explicit inputs and outputs. Get some test cases down.
Okay.
And don't even think about coding yet. Just use your brain. That's a little bit of a cheat code because typically you're not, using your brain for an algorithm type question. But think of it. This is honestly a cheat code because you have human intuition that the computer doesn't have.
Right.
So use that cheat code.
Right.
So then, for example here, how would your brain work through this kind of input? How would your brain work through that kind of input? How would your brain work through this kind of input, right?
Yeah.
So think about just intuitively, what would you do? And it's like that can unlock a little bit of information for you,
Right.
right?
Right.
And then see if you're understanding the problem correctly. Lucky enough for you, you did understand the problem correctly, but sometimes the problems are a little confusing. So
Yeah.
double check that your intuition matches the interviewer's request.
Right. Right. Yeah,
Okay.
I did this problem like a week ago or 2 weeks ago. I was literally doing stacks. I was like, yes, I like stacks. I know how to work through them. Once you told me, once I heard the strings, I'm like, this is a stack question. This is stacks question.
Sure.
So I was thinking like okay, maybe it's not gonna be the same ones that have been done, or like it's gonna be pretty similar, but I know it's a stack question.
Right.
And
This is
then
a
I
pretty
just
common question too.
yeah, I just blanked out. Not gonna lie to you, I just blanked out. I was like, I know this, the solution is coming in. And then I was thinking of the if statements that I made during the legal session that I had, and I forgot.
Yeah. So
I,
here's the next
I
thing
for,
that I would recommend you do here is apart from the test cases, is go through some pseudocode.
yeah,
So write comments that talk through your thought process. Work through a solution in half English, half code.
half English, half code. Can I do half Spanish?
I mean, maybe it could work if you have a Spanish interviewer, but I would guess that most programmers don't speak Spanish, which is something that I'm trying to change personally. But that would be my guess.
Right.
And here's another thing:
That's scary.
visualize your variables. This is another cheat code here that I'll talk through. And notice this technique that I'm going to use here. So if I have a stack and it looks like that or something, maybe it
Yes.
looks like that. One thing that I like to do a lot is I'll literally just get one of these little carrots. This is called a carrot, and I'll use this as a pointer, and I'll talk through
Mm,
like this
that's
is
very
I'm looking at
very-
that, I'm looking at that, I'm looking at that. So it's like you
that's
and
a,
I both see what I'm pointing at.
that's very nice trick. Yes.
So visualize your variables when I talk about this. And sometimes you need two of them. There's sometimes like two pointer approaches, right?
Hmm.
You can do one of these, one of those. Sometimes you can even do I and J if you're working
Yeah.
through indices.
See.
So use this little trick here to visualize your variables. Use carrots, use I and J. Because that one will help you work through kind of like little fine details, especially with like these iteration based problems, because you have to work one by one by one by one,
Right. Right.
right? And same thing works with
One.
S. If your S
Right.
is this or something.
Yes. Right. Right. Right.
Okay.
One thing that was I think one thing that like fucked up my mindset was the I forgot the long name of it, but the loop of hell. Like at some point I was like, are you serious, Rafael? Like, are you serious? You can't do this. Oh, come on. This is such a basic problem. I shouldn't be, just thoughts. And then during I kind of mentally gave up, but I was like, nah, you got this. So, like, try to talk it through, even though you're not going to get the solution at the moment. Try to, like, explain your thought process. Yeah, Yes, that voice.
So the audio died towards the end of our recording. So I don't have the end of the discussion with Rafael, but I can tell you through the last few things that I did share with him was that there is a voice in the back of your head that will doubt you throughout the entire interview. You'll think that, oh my God, I did this problem just a few weeks ago and now I totally forgot it. What's going on with me? And like, I just don't know like what to do. And this can lead to feelings of imposter syndrome and doubt and the feedback loop from hell, which is a term coined by Mark Manson. But my tip for you is to just breathe slowly and focus on a long exhale to lower stress. One of those will help you go into the rest and digest part of your nervous system and just lower your stress immediately. But a cheat code that I have that's useful for the interview itself is also to say, can I get a minute to just think about the problem in silence? And not enough people know about this. Like, it's perfectly acceptable for you to just sit and ponder for a moment. Most hard problems require deep thought. So just use a minute just in silence to kind of just stare at the problem. Think about it in the back of your head. And there's a good chance that you're going to come up with garbage first. It's just kind of like opening like a faucet that hasn't been opened up in months, right? There's going to be some like brown murky water that comes up out first, and then eventually the clean water will eventually come through. Let that murky water come out through your thought process in silence at the very start of the interview versus out loud to the interviewer when they're listening to you. Let that murky water come out and just keep it to yourself. Don't let them know. And then eventually the clear water will come through and then you'll have something. And then you'll talk about it. And, don't take too long. Just take a minute. Another thing that I mentioned to him was to not throw away comments or ideas or code. You can move them to the bottom of the page so that they don't just disappear because you want to section off the page. Maybe you have notes at the top or code at the bottom or vice versa, just so that you have some bit of structure so like, okay, my ideas are up here. I'm just brain dumping stuff. Like thoughts are flying. They go into the top of this section here. And then my actual code for my solution is at the bottom. And again, also, when you have an idea and you decide to pivot, that's perfectly okay. Like the nature of code is that it's iterative. There's always version 1, then 2, then 3, then 4 in the real world. So like it's perfectly acceptable that your solutions will evolve over time. Don't abandon them and just like forget everything that you did in the past. Use that as knowledge that maybe this was going in the wrong direction. Let's try to pick a different direction and hope that that's the right one. And then the last thing for Rafael that I think was super valuable was code style and variable naming. I think this piece of feedback was very pertinent for him in particular because it confused him to see him go through some of the variable names that he came up with himself that weren't the most clear. And I think one thing that helped me a lot personally grow through I think something that helped me a lot personally was going through Google's style guide. They have style guides for all these different languages. Primarily for Python is the one that I know personally. That teaches you about how do you name variables properly? How do you space accordingly? How do you section your code? And how do you write prosaic code or code that reads like prose or reads like English? It's just the nature that code is read more than it is written. And so you want to have an emphasis on readability because it helps your interviewer understand it. It helps you avoid confusion too. So stay organized, stay readable. You can read the Google style guide for Python and that can give you a huge head start. And if you're interviewing for Google in particular, like this is awesome news because it's what the company already uses. Here in particular, I gave him some specific example. Instead of calling it my brackets at temp char, like maybe call it something like pairs or complements or closing brackets. And I would avoid using I as a variable name unless if you're looping over indices. If you're doing characters, I would use C or X or char or something like these variable names to make a bit more sense. And I kind of threw him off a little bit here, and I made my input string called S. I wanted to see if you would rename this because my function name at the top here was quite long. Check for balance parens. And I think that was very illustrative of a good function name Sure, could this be better? But let's not debate about that. But this input is just S. Like, maybe we could have called it input string or paren string or brackets or something like that. Like, depends on how you think. You can come up with something on your own. And I honestly believe that if this costs you a few extra seconds of typing, that's well worth the investment for the clarity that you'll receive just with a few extra seconds. Like, I'd rather my fingers hurt and my brain not than my fingers be like, I only just typed like an X. And then my brain is like, oh, what did that X mean? So keep that in mind. A last few things are just kind of random points that came up. Was you have to ask clarifying questions. Like, you need to ask, like, what are some example inputs and outputs? How big are the inputs? Can I assume empty inputs? Has validation occurred already? Can I reuse an existing algorithm like sorting, or should I implement that by hand if the question calls for it? Another big one is asking your interviewer, what do you think about that? Because chances are, like, this may be the right approach. This may not be the right approach. You have to talk to them through it and hear what they think. Definitely, like, there was also some minor spelling mistakes, and I gave him some advice on typing speed if he wanted to improve his typing, which I think this is huge as well. But circling back on this point up here at the top is just like as a bit of like a mental reframe, assume you already have the job. Seriously. Assume that you already have the job. Just like you're a team member on the team and you're just talking with a coworker about how to tackle the problem. It's you and him, not you against him. So work together to actually make that connection and to like that conversation about the problem. Because there's this us versus them mentality that occurs with interviewing because it's an assessment or because it's a test or it's an interview, right? But think of it more of as just a discussion. And there's this kind of like this confidence that you walk into the interview with when you feel like, nah, I already got this. This is a shoo-in. Like, I got this at the bag. Just enter with those sorts of initial conditions to the interview once you click join on the Zoom link or whatever. And you'll feel like, oh, like I got this. Like it's easy. It's in the bag. And maybe you can argue that this confidence is earned over time, but try it. Maybe this will at least fake you into it. Fake it till you make it, But that is all that I have for you today. And if you've enjoyed this, please make sure to like, subscribe, leave a comment. And if you'd be interested in doing one of these mock interviews yourself, definitely shoot me a DM, and I'd be happy to talk with you through one of these problems. All right, man. Take it easy. Peace out. Hey there, what's up? So what you're about to watch here is a quick mock interview that I did with my good friend Rafael. Rafael is a student at the New Jersey Institute of Technology studying computer science, the same major and university that I attended to. And this interview is supposed to mock what a technical coding interview would look like for a software engineering role at any large tech company, small tech company, you name it, anywhere in between. It's a software engineering role, so you have to know how to code, and that's what this video covers. In the first part of the video, we'll talk about the hiring process at large, talk about what it's like to get recruited, talk about the online assessment, as well as the technical interview and expectations amongst those three components. And then we'll dive into an actual technical interview problem. We'll walk through a code question, and he'll walk me through his solution. He'll write something on the fly in a Google Doc, and together we'll walk through how to optimally solve this problem. I get to see a little bit about his thought process. I get to see how does he code. And then at the end of the video, we'll go through some feedback and some actionable steps, how to improve and find areas of improvement in terms of code style, in terms of code technique. And then in the end of the video, we'll talk about how to improve on code style, variable naming, and also your thought process and your mindset when it comes to an interview. And I don't mean to sound very woo-woo, but really your mindset is super important for technical interviews and arguably everything in life. When it comes to the technical interview, you have to come into it with the sort of confidence that you've kind of already got the job handed to you. You've got it secured. It's in the bag. And with that mentality, you'll go far. You'll walk in with the unsurmountable confidence that the interview can't even shake. Because you'll be treating them not as someone who's assessing you, but as someone who's a teammate on the team that you've already landed a spot on. So, join me in this video, watch Rafael go through this problem, and see kind of what it's like to actually walk through a technical interview. I'll see you on the other side. Thanks for watching.